In this tutorial, we'll learn how to create a cathode ray tube, or CRT. We'll learn how to manipulate the output on a CRT screen, and then we'll show how a CRT was used to learn about electrons. Let's begin. We'll start with a sealed glass tube, like this. We remove the air from the glass tube, creating a vacuum, as we don't want air interfering with our traveling electrons. Now, within the tube, we have a heating filament here that enables us to free up a bunch of extra electrons. And free electrons means a buildup of negative charge. So we call this negative region the cathode. Considering the name CRT, and you now understand the cathode part of the name and the tube part of the name, so what's next? The ray part. So the ray is a stream of all those excess electrons at the cathode being accelerated through a voltage difference in here. And then the speeding electrons continue on until they collide with a screen over here. The ray is the stream of traveling electrons. So how exactly do we accelerate these electrons to form a ray? Well, we'll put an anode or a positively charged ring here, so that the free electrons are repelled by each other over here, and they're really attracted to the positive plates in the anode area. And that results in a force that gets them accelerating down the center of the tube as a stream of electrons, or a ray. And as the electron stream collides with the fluorescent screen here, it causes a glow, which is seen on the outside of the tube as a nice little glowing dot on a screen. So now that we have a CRT and a nice glowing dot on our screen, well, from there we can start to play with the electron stream and move this glowing dot. So one of the first experiments with a CRT was by J.J. Thomson, when he found that he could deflect the electron stream with magnets and/or voltage plates, moving the dot. So let's consider the way that this could be done with the voltage plates. If we put plates like this within our tube, say one above the electron stream and one below, and we put voltage on these plates, say the top plate is positive and the bottom plate is negative, well, what do you think would happen to the ray or stream of electrons? Pause and consider this. Did you determine that the electron stream would be deflected upwards? Nice. As the electrons travel between the plates, they're attracted to the positive or top plate, and they're also repelled by the negative bottom plate. And this causes the deflection of the stream. And the glowing dot, well, it moves upwards. We could even move the dot further upwards by adding a greater voltage to these plates. This simply causes more attraction to the top plate and more repulsion from the bottom plate. If we switch off the voltage going to these plates, well, we're back to a straight stream and the glowing dot is in the middle of our screen. So what if we wanted to move the dot downwards? How would we do that? Pause and consider this. Did you determine that we changed the voltage on the plate so that the bottom plate was positive and the top plate was negative? Perfect. In the same way as before, the electrons are attracted to the positive plate, which is on the bottom now, and repelled by the negative plate, which is on the top now. So the deflection is downwards. And we realize that we can move the dot up and down to wherever we want on this screen. And if we wanted to move the dot left or right, we'd simply apply the same concept, but where the plates are on the left and the right side of the electron stream. By controlling the voltage on these plates, we can deflect the stream left or right. Thus, by controlling voltages, we can move the dot anywhere we want on the screen. We're in complete control. Using the right voltages, we can not only control how fast the electrons travel in the ray, but then we can also control the deflection forces, up or down, or left or right. And this principle led to a lot of inventions, including oscilloscopes, lots of medical equipment, and the original TVs and computer monitors. And back to J.J. Thomson, well, back then, finding that voltages could predictably deflect the beam in the tube led not only to confirming the existence of electrons, but also allowed a better understanding of electrons' mass and charge.